Pre-treatment series. We're starting off with showing the PPE here. So we're always going to be wearing a face shield, and then safety glasses. We're not showing it on this figure, but hard to show, but we're always wearing a face shield and safety glasses. That's to keep water and chemical out of the operator's eyes and face. So if you're in the wash bay, you're using a pressure washer, a lot of blowback from just water chemical mixture hitting the part and then blowing back at you and hitting you everywhere. So the face shield helps protect the face. Half face respirator, that's to keep the operator from breathing in chemical vapors. And those are really present when we're in the wash bay and we're using all those different chemicals to do the cleaning and pre-treatment. And then kind of moving down here, we've got the rain jacket, got rain pants, got boots. So those serve two purposes. One is to keep the operator dry because they're in the wash bay all day long and every day, so we don't want them soaking wet. As we're keeping them dry, that's keeping the chemical off of them. And so that's important because we don't want that to get absorbed through the operator's skin. Now, when we're in the wash bay, the chemical concentrations that we're using when we're doing pre-treatment for powder coating, the concentrations are pretty low. So you're in like 1 to 3%, maybe 5%. And so what does that mean? If you're at 1% concentration, you got a gallon of chemical to 99 gallons of water. So the chemical is not very potent. If it got on your skin, bare skin, it's not going to burn you immediately. It's probably not even going to cause any irritation, maybe just a little bit. The issue that you're going to have if your operator isn't wearing rain jacket, rain pants, boots, and skin is just exposed to the chemical, if they're in there all day, every day, over a long period of time, that's not good to always have that chemical on your skin. Even though it's in low concentrations, that can get through your skin. You can absorb that into your body, and you don't want that. So it's really important whether your operator's in there just for a couple hours a day or even one cart, so half an hour, all the way up to they're in there all day, every day. They really need to be wearing the proper PPE to keep the chemical off of them. Keep them dry for one, but two, to keep the chemical off of them. And then also up here we have chemical gloves on as well. So we want to make sure that operator's hands are protected and we're not getting chemical basically anywhere on the operator's body. When we're in the wash bay, we're trying to stay fully covered to keep chemical off of the operator. In the summer, that gets very hot because the shop is hot, the wash bay gets hot, and then we got all that humidity because you've got a lot of water and mist in the wash bay. So inevitably the operator ends up wet, but it's typically because they're sweating so much. One of the first steps when we're doing pre-treatment is to decide how we're going to do it. What chemicals do we need to use? One of the main things that we look at is, are the parts greasy, oily, or not? If they are super greasy and oily, you're going to need some sort of degreaser, typically an alkaline cleaner. That is going to cut through the grease and oil really, really well, meaning it's going to clean it, cut through it, and they'll get rinsed away. So now you've got a clean part that you can start to do some sort of conversion coating on. If the parts aren't really oily and greasy, then typically at Kaiser we like to skip the degreasing process or the alkaline cleaner. And the reason for that is because if you're using an alkaline cleaner, you have to be very, very careful. If you leave behind alkaline cleaner on a part, meaning it just doesn't get rinsed well enough, an area gets missed on the next couple stages of the pre-treatment when you're doing it manually by hand, that could happen. And so you have an area that just has alkaline cleaner on it. It's clean, there's no grease and oils, but that residual alkalinity that gets left behind, if powder coating is applied directly over top of that, the powder coating does not like to adhere to that residual alkalinity, which is a high pH area, essentially. And so the powder will just fall right off in huge sheets, so there's essentially no adhesion whatsoever. So you have to be very, very careful of alkaline cleaner. It's a great tool to help clean greasy and oily parts, but if it gets left behind, you could have even worse problems than you had to begin with when you had grease and oil. How can you check for that? If you're curious and you want to know, or most of the time it would be if you had a failure and you want to figure out, was that because that there was residual alkaline cleaner? If you had a huge sheet of powder fall off. When I say huge sheet, I mean 1 foot by 1 foot, just fall right off. If you take phenolphthalein, that's an indicator for titration. Typically, if the powder has just fallen off in a sheet, if you drop some phenolphthalein on the back of that. Phenolphthalein will turn pink if it's going on some sort of alkalinity. If you see that, then you know that you have residual alkalinity that got left behind, and that is not a good thing. So if we are pre-treating steel, what's the process? This could vary just a little bit, but in general, we're going to start with a degreaser, some sort of alkaline cleaner to clean off the greases and oils. Then we're going to go into a city water rinse. So we're rinsing away the alkaline cleaner, we're rinsing away the oils and the dirt and the grease. Then since we're on steel, we're going to use a phosphate. When we use phosphate, that's an acid. It usually has a little bit of a cleaning package in it still, so it's going to clean the parts just a little bit more. And then since it's phosphate, it's going to start having a chemical reaction with the steel substrate, and you're going to create an iron phosphate coating. And what is that doing? That's keeping the part from rusting a little bit, and it's also going to help with adhesion. So the powder coating is going to stick better to that iron phosphate coating that you're actually leaving behind on the part. It does help with rust prevention a little bit, but you can't just phosphate parts and create an iron phosphate coating and then just let the part sit outside. It's eventually going to rust. So the phosphate, when it creates an iron phosphate coating, it will help with some corrosion protection for a while, but you really need to get the powder coating over top to create a really nice, good all-through coating from what you left behind with pre-treatment and then your powder that you put over the top. Depending on the phosphate that you're using, you might need to do some sort of rinse at the end. Other phosphates will just dry in place. For your final rinse, you want to use some sort of purified water. It could be RO water, reverse osmosis water, or it could be DI water, deionized water. You just want something that's purified so you're not leaving minerals and deposits and solids, is what we call them, behind on the part for your final rinse. Because if you have pre-treated the part, you've cleaned the part, you want it to stay clean. Even if it's just regular city water, you're leaving some mineral deposits behind, and that's not good. For pre-treating aluminum, roughly the same kind of steps that we would do for steel, but we just have some different chemicals. If the aluminum is very greasy, an alkaline cleaner is going to really help cut through that, so we could use that for our first stage. Then we're going to do a city water rinse again to rinse away the alkaline cleaner and the grease and oils. On aluminum, we're not going to use phosphate. It won't react with aluminum. It won't create a coating on aluminum. You have to have steel for that. So since we're on aluminum, we're going to use a strong acid, low pH. Lower the pH, stronger the acid. We're using it to etch the aluminum. We can get away with it with a really strong acid because the aluminum is not going to flash rust on us like steel would. So we've done some sort of acid etch, which is going to give us better adhesion to the aluminum. Now we're going to rinse that away. So we're doing a city water rinse again. And then we're doing some sort of purified water rinse. Again, that could be RO water. Reverse osmosis could be DI water, deionized water. Now we have a clean etched aluminum part that has been rinsed clean. We haven't applied any conversion coating yet. We need to put a conversion coating on that aluminum to help promote adhesion and to help with some corrosion protection. We can't use phosphate. We're using zirconium on aluminum. We're building a coating of zirconium on aluminum. That's typically going to be the final stage of your pre-treatment process for aluminum, because usually a zirconium is built in with some sort of sealer, so it's typically a final rinse that your zirconium is in, or if it's not formulated that way, maybe you have another final rinse that is your purified water. So on aluminum, we are leaving behind a conversion coating. It's just zirconium, whereas on steel, when we leave behind a conversion coating, it's iron phosphate. My favorite thing ever, pre-treatment: time, temperature, concentration. Extremely important. If you remember those three things, time, temperature, and concentration, you're going to do good pre-treatment. What do we mean by time? It's the time spent on the part, the contact time that the chemical has on the part. Temperature. If we increase the temperature that we're using our pre-treatment chemicals at and water, we get better cleaning, and we actually get the chemical reactions to work a little bit better for the conversion coating, and we end up with a cleaner, better pre-treated part when we have temperature. Do we want it boiling? No, that's way too hot. We just need 120 degrees Fahrenheit. You could say all the way up to probably 180 degrees Fahrenheit. Somewhere in that warm range where you're not creating steam or boiling. You don't want to be that hot, but in some sort of warm range, that's going to be the best area temperature-wise for pretreatment. And then concentration. So how much chemical are you using in your mixture? If your concentration is very, very low, obviously that means you don't have very much chemical, so you're not going to clean as well. You're not going to put on as good of conversion coating or as thick of conversion coating because you just don't have the chemical there. If you have excess amounts of concentration, you're going to clean very fast, and then you're also going to deposit maybe excess chemical on the part far beyond what can even be reacted with the substrates. Now you end up with this nasty chalky chemical that's left behind that you need to deal with. So concentration is important. You don't want to be too low, you don't want to be too high. Time is just going to typically vary, right? So if you have a really, really dirty part, we need to increase the time probably. If the parts are relatively clean as they're delivered to you, maybe the time can kind of go down a little bit because you don't have to worry about getting them clean because they've already came to you with hardly any oil on them. If you're going to have really, really high concentrations, you probably can get away with lower time. So these kind of interrelate with one another. If you use more chemical, really, really aggressive chemical concentrations, you probably can go faster. You got to reduce the time. If you are using really low chemical concentrations, so not very much chemical, you're probably going to have to increase the time, right? If your chemical mixture is not very potent, you have to spend more time trying to get the part clean, getting more chemical on there. There's a happy medium. Just because you want to go really fast and just raise your concentrations way up, you can get it out of hand. There's a balance between time, temperature, and concentration. Final part of pretreatment, we need to get the parts dry. Typically, we're going to utilize a dry-off oven for that, but as you can see here, we also blow parts off. When we're blowing parts off, ear protection is very important. Anytime you're using compressed air out of an air gun, it is extremely loud. You need to wear ear protection like this guy has up here. When you're blowing parts off, you want to look for areas that have nooks and crannies that are catching water. Any pinholes in the welds or area where water could have got inside something, we want to try to blow that out. The more that we can get the part blown off or pools of water blown off of the part while we're in the wash bay, the better chance that we get a better drying and the dry off and the parts are actually dry when they come out. If you got pools of water on the part in places, sometimes the dry off won't get all of that gone because you have a huge puddle of water that had to like boil off and didn't have time to do that in the dry off. That's why blowing off with compressed air is really important in the wash bay. The one thing that you need to make sure, you have to have clean air when you're doing this, because if you just cleaned and pre-treated a part and your air is oily, then you're just spraying the part with oil again. And you may not realize it, you might not be able to see it, it's more of maybe an oil mist, but that really can wreak havoc on your entire process if you're not paying attention to that. Drying the parts is really important, blowing them off with compressed air is really important, but the air needs to be clean and also dry. If there's water vapor in your air, then it does no good to blow parts off with water vapor ridden air.